Good day, everyone. Yeah, this is Jamal again, and this is still on the perfect cuboid problem. And in this video, my goal is just to share some ways I would use computational assistant, AI assistants to, generate lean codes to satisfy, to uh, formalize my work on perfect cuboids. There are three possible pathways of considering exploring, which I think I want to. I'm just putting once again my ideas out there. I'm just throwing things out. I'm just throwing things out. And like I said in my previous video, I'll be glad to take in feedbacks. Things ways I could approach this program properly. Just anything. Once we are inching towards a full solution to this problem. And so yeah, one idea I had was, to let me put something down. I mean, this is just me putting my thoughts out as you see it live. It's pretty much live streaming my own ideas. So my own idea was, how do I say it? To go to GitHub. I'll share my screen and go to GitHub. Okay. Yeah. Yes. So this is my full screen. So there are three ideas that I'm going to try out. I'm not going to exactly go deeply into them. I'm just putting out pathways I would approach about three different pathways I will approach trying to use AI models, but I'm not going to be over dependent on AI. No, because I truly understand that you can't leave AI to their thinking for you. Just pathway, just more like I'm throwing out ideas. If this idea does not make too much sense in approaching the full proof, and there's anyone out there with full insight into how best I could go about things, once again, I'll take in feedbacks. I'm just putting out thought processes out there. So one thing I would have done was to go to this GitHub, you know. Yeah, this was my previous PDF, but I've since improved it in a different, in a different repository. So this, okay, let's see. I think this was generated hmm, by Claude AI. This was generated by Claude AI. Yeah. So one idea would have been, to take to look at these codes generated by Claude AI, you know, to yeah, this was the yeah, Claude AI, to copy paste them like this, and maybe go to a different AI model, maybe ChatGPT or DeepSeek. Let me check something. DeepSeek and see something. Um, oh boy, I have to come and go to my phone. Let me see. Um, I'm making a few changes here and there. I'm coming out about something. Yeah, let me see. I'm checking what I'm coming. I'm just doing putting everything live as I'm doing things. I'm not this. I'm not going to edit this video, so I'm going to, I'm just me putting things out there. So I'm just making some changes on my deep seek. Um, and so, yeah, so the idea would have been to, copy paste this, go to deep seek here, and then let's see, for instance, I copy paste it here, you know, and try to, get it to correct any errors, you know. So I'll continue to filter things down and see whether it leads to a very correct lean formalization, which works, you know. This is one way I would have done things. Or another way would have been to, this from something else. I don't know. So my first idea was involving taking my code generated by Claude AI and try to put it into different AI models to try to get to correct one lemma after the other to fill possible gaps. Maybe let me see what I can still find that whatever I did that. Um, to get to fill possible gaps, you know, if there were any sorries or something, how to improve them. I would have done something like that, you know. Or I would go to another idea is using VS Code. So the first idea I said was using oh, Claude AI. Some of the formalizations generated by Claude AI and filtering it through another AI model to try to correct errors, any possible errors. So let's see something. This is the same one from the Claude AI. So let's copy paste it now and put it into a different somewhere. And see what happens. So there's one error. Maybe we'll continue to ask um, DeepSeek to correct any possible errors. Or, I could also leave this Claude generated proof, sorry, formalization also on my description section. If anyone sees any way of correcting these codes, I'll gladly take it and give due credit if I'm to put it in the paper. So I'm welcoming ideas. And if there are any ideas that will lead to a proper formalization of this code, I give full credit. I'm just putting things out there, trying to welcome ideas because I would like to get this problem solved if I could, and if anyone could be of substantial help, I take it. You know. So this is from the Claude AI proof. The second way is to go to VS Code. Mm, VS Code here. So here there were some proofs, there were some formalizations generated. So for instance, something like this. This was a template generated by VS Code. You know, I'll copy paste this. I don't know if I already did somewhere else already. I put this another approach. This is a second approach. It to take this, you know, and maybe put it into also DeepSeek this way. So I'll remove this and maybe take one theorem or lemma where there's a sorry and try to get DeepSeek to fill in whatever gaps that are there, you know. So for instance, mm, maybe it's, let me for now see. So see something. Yes. So indeed, it says that some of the most of the proofs that are marked with sorry indicate that they need to be completed. So the idea would have been to, go here. I'm not going to go into detail. I'm just giving possible ideas I could have used. The first idea was to um, take the Claude AI generated lean formalization, put it into DeepSeek or any other AI model, which is somewhat good enough, dissect one lemma or theorem after the other and get it to, correct whatever gaps there are. The second idea is me taking a VS Code, the GitHub Copilot generated proofs or whatever on VS Code. So for instance, I could say, let's go here. Um, this particular lemma, for instance, we see a sorry over here. We see a sorry over here. I could say that, I could copy paste it here and be like, with regards to this lemma, I could ask it, you know, why does this sorry command exist? Um, what possible gaps could be filled here? You know, what possible gaps could be filled here? You know, so I could put this over here. So let me jot some idea now. I could ask it to fill. Convert to that equivalent. Okay. So I've noticed some things now. Yeah. So with regards to this particular lemma, you know, this is what it's doing. So let's see something. So I could think of some. This is just one particular lemma I took. I could now say, do you mind filling those gaps? So we are trying something. No color a bit. Yeah, simple none. This looks great. So DeepSeek has generated all of this. Okay, it's still busy. the key gaps that remain. I could still go on to ask it to fill in whatever remaining gaps that are there, you know, and then translate it into, you know, latex. So translate. It's just an idea. After it, I'll summarize whatever I'm trying to do. Into overly. This is how I would have approached the proof. So this is how it should have done it. So we are just watching procedure unfold before our very eyes, you know. And from the look of the general of the formalization, from what I'm seeing, it this looks like something that I can easily explain in layman terms, you know. For things concepts that are above me that I do not understand, I will make it clear that I do not understand this, and I will only take expert feedback that it is 100% correct. You can add it into your paper, you know. Because I would like to make sure there's 100% credibility as well. So if there's something I don't understand, even from this, I make it clear to you that I don't know, I don't understand it. But if there's expert feedback that this is correct, I'll now feel confident to put it in, you know, citing expert feedback. So this looks like something I could explain on my own. So now, so far, the idea now was, to, you know, the first idea was to take the proofs, the link normalization generated by Claude AI, put it into another AI model like DeepSeek, which is quite good at mathematics, and get it to, you know, correct certain errors, whatever. Another idea, the second idea I did was that based on a previous code generated by uh, GitHub Copilot on VS Code, you know, which I showed you over here, a very long stuff. I could take one particular case, one particular lemma, theorem, take it, the whole thing, get the AI model to fill in whatever gap that there are, especially if I do not have any deeper insight. It's only onto me to look at the answer it is given to me to see if it makes sense mathematically, if it's logical, and then whatever changes I need to make, I make it before putting it into my paper. You know, there is an idea I could follow up for each and every single lemma I propose in this particular paper. You know, and so um, yeah, this is all of that. I think charge this. So, uh, yeah, I think something about my speaker. So right now, yeah, another thing I was thinking is if you're to look at some of this lean formalization that I tried with whatever AI model, not this one, I think there's another one which looks almost flawless, but there's only one error from this. And the last time I made feedbacks around that, I sought for feedbacks around that. I learned that it's because this proof was formalization was largely generated by AI. Sometimes the math lists of preambles that you see over here might not necessarily exist as you can find them. So yeah, there was a website. There's a website. Hmm. Oh, let me do something. I recently got a mail from a math professor who suggested that before I talk of correcting some of these errors, I would have to make sure that whatever math lab list I'm using, it's found in the library, in the website, in the Lean website itself. Let me see whether I can go to the website and do something. Let me see whether I can find it. Uh, okay, I think it's this. So I think math lab. So I think, yeah, something like this. I'll have to go here and see whatever things I'm using over here, whatever things I'm using over here. Wait, yeah, whether this makes sense. So I'm going to go into data nut and see whether I can find it. Data nut. So let's look at something just to make sure we're using the right libraries. Let's go here. No, here. Look at this. This data, this data is here, right? The nut you see here, the nut you see here, you would find it when you come down here, right? And then the prime you see here, if this preamble is correct, you should see prime going down the nut. So let's see. Nut. Yeah. So we see, so come down here to be sure that, so I think the code generated by VS Code, the Copilot, it seems this makes sense. So when you come here, you can see data, nut, prime. So it makes sense. So let's come here, data, nut, GCD. Data as we saw it, nut, GCD. So once again, if I'm, okay, okay, and import algebra group power. So I'll go to algebra, find group, and descend to see whether we can find power. And if it turns out that all of these is correct, it would mean that if you have to follow this path, try to use AI models to correct each and every single story we see, try to get to fill in whatever gaps that there are, we can inch towards fully solving this problem. But once again, I'm trying things out and I'm putting this out there to welcome ideas and to get feedbacks, you know. Sorry. I don't want to talk bigger than myself for the sake of credibility. I don't want to talk bigger than myself. So far, I'm going through certain things that we have done. We have tried to use some of the lean formalizations generated by Claude AI, which earlier showed that we could put it into DeepSeek or any plausible AI and get it to correct whatever flaws that there are. The second idea was to take the codes we find from VS Code, like what we showed you earlier, as you have seen here. This is the same one. And then, based on this preamble, if you can be sure that all of these preambles are correct, then we can, based on this preamble, to ask this AI to generate lean formalizations based on my own PDF, and if there are any other gaps to fill, at our own time, we could go into that into full detail. But this video is meant for oversight. Uh-huh. And so once again, let's verify whether this algebra group power is indeed found in the library. If it is found, then this means this is pretty plausible. We can only focus on filling in those gaps. Uh-huh. So let's see. Let's go to algebra group. Oof. Let's see. Oh. Oh man. So let's see. Oh, don't do that to me. Algebra group
We don't see power over here. Let's see. Group dot power. We don't see any power. Let's see. Yeah. So that means we can't trust this particular one. But these two are found in the website. These two are found in the lean website. So we can just try to see how we can maneuver this. Yeah. And with this sounds these videos are pretty much technical. I'm just putting out ideas there, you know. Yeah. It's time for yeah. Prayers. So yeah, these some of the ideas I had. And that's one other idea too, you know. Yeah. And the last idea was, especially since we know that these two are found correctly in the website of Lean, you know, based on the previous Lean formalizations suggested by ChatGPT, you know, we could try to ask ChatGPT. But once again, these are ideas I'm putting out there. You know, we can't always trust ChatGPT, so I'm very mindful about me using ChatGPT. But once again, I'm throwing out ideas. You know, so the previous code generated by ChatGPT. Let's go to my previous video. Tube. Okay. Okay. Overview. Lean. Yeah, this.
Yeah.
Wo-
Hello, everyone. Good day.
So when you come
You
to
know,
this video, this old video of mine, you'd find out that I made mention of ChatGPT, our previous correspondence. And so when you go here, I think I hope my line of thought is not very difficult to follow. And so you find out that ChatGPT suggested some, you know, which looks like it makes sense. You know, I just don't understand it well enough to boast on that. So this was the last video, the last codes ChatGPT suggested. And since we now know that these two are correct, we can try to ask ChatGPT that based on these two libraries that we are sure of, you know, or maybe import algebra group, you know, but we can't we have to know how to talk about this. We can based on that to ask ChatGPT, where is that? To generate proofs, lean formalizations based on my previous work that I showed to it and see what happens. So these were the three ideas I had. So for a bit of insight, the first idea was to use the lean formalization generated by Claude AI, try to get DeepSeek or any AI model to correct any errors. The second idea was to use the formalizations generated by VS Code, which look a bit promising to me so far, you know, and based on the reliable this ones, we can now I think ask ChatGPT to generate lean codes based on the previously generated codes that we saw. We look promising. So I hope I did not intend to make this video very long, but these were just ideas I had, which I'm just putting out there. So right now, I think these are just exploratory ideas I'm throwing out there. You as time goes on, I'll delve into these and see how far we can go. So on this note, I would like to end this video. So far this is how far we have come, and so yeah, so far for those who have been able to get to this point, if you have followed me up to this point, I know this particular video, sometimes talking about formalizations, lean, going through these open problems, it sounds very technical to follow. Even I myself, there's a lot to learn that I don't know. I'm still yet to learn. I'm just using very big English, but I myself, there's still a lot to learn. I admit so. I'm putting these out there. So for now, ciao. I'm ending this video over here. So yeah, au revoir.